This is a bit on the next layer, so to say, from this physical layer, and I think it is actually something that I am not aware of that any of the big cloud providers have addressed in their services. But it is still a research topic also. I hope I understand your question right, but how to handle the data, how to handle the metadata, to couple this to the data, and how to, for specific data, have some persistent identifiers. And to some extent, this is still a research topic. But there is a definite need. We see it in different areas of research where you're collecting data from in different areas, from life sciences to physics, really. How to, on a really long-term storage and archiving of data, how you can go back and find it. What is basically technologies in terms of that have been known in the library business for hundreds of years, but now we have to do it electronically with much more data.
I think there's one practical example also that let's say a DVD movie that is stored in a few hundred computers owned by different people. It's not illegal as of now. It only becomes illegal when you assemble it.
Maybe I should go first on this. So, this is an interesting question, because it's very much dependent on, I mean, what is the present commercial offering then? And it's very much dependent on what type of number crunching you want to do. So, if we are talking about really large problems that requires huge amount of memory in so much that you need to parallelize your jobs, have clusters of computers with fast interconnects and so on. There are very few commercial offerings here. I mean, there are from some of the cloud vendors available, but quite expensive. I would say not really worth it. If you are, on the other hand, in the what you could say is still a lot of number crunching, but on throughput computing. You have a lot of smaller tasks that need to be done. Then actually some of these commercial offerings that are available today from these gentlemen are still, can be very useful actually. Because you have it's just a huge number of processes that you need to start with a reasonable amount of memory on each of them. That's their environments can be used for. I think we will see maybe more of these HPC type of services because there is not only I don't know, maybe I should put this question to you, what you see from because of course HPC also in the business area is a big thing. If you go to industry, I mean anything from automotive industry to pharmaceutical industry, they do a lot of high performance computing, and usually they do this in their own facilities because the material that they are working with there is really core of their business, so they want to be very much in control of these environments. So I'm not aware that they are really going to Microsoft and so asking for HPC services in the cloud. Maybe that would be interesting to learn. But it will definitely come, and there are these vendors are now also moving into technical computing and this area with this offering, because it is a huge business out there for it.
I don't think for that particular problem that you described, I don't think there is very much use in something like our Azure. But as you said, if you have a problem that you can describe in a number of different programming languages, and it does not, the processes do not have to be connected at the processing side. certainly we have customers who do that now already on Azure. They get a huge number of quote unquote machines in our data center for a very, very short period of time. We might be talking about days or maybe weeks. And then use those to handle, compute a particular issue or problem or whatever they have and then they just give those away. We don't even store any of the data. The data is just passed onto the machine and then passed back to the customer's environment. And for those types of problems, certainly it is one of the options. And as you can, on Azure, you can use a large number of different kinds of programming languages and environments. It's not just Microsoft. You can do PHP or Java or basically, I think there's 6 or 7 different possibilities. So certainly that would be one thing to consider. But again, I think in the case of the automotive problem, again, this is it probably has to do with data governance again, because that is data that they probably do not want to really pass out of their own systems to us or anybody else outside of their walls.
Just a quick, to add to Kimmo's comments, public reference for Windows, Azure, or Azure is BMW. They use up to 50 virtual machines to run simulations. And just like Kimmo said, I mean, it's just a matter of them designing stuff and just pushing the data out, doing computational stuff, and pulling the data back. So BMW is a current customer and running stuff off of Azure.
If you have a use case that is more like Per mentioned, throughput computing, where you easily parallelize and very many small jobs, but still maybe you need some of what we call right now HPC facilities on, like Amazon. They have 8 core machines that you can get, but it's not what we call a real supercomputer here at CSC. But the thing is that what I want to come to is, if you have some task that is really quite big, and maybe just for now, and then you do it for 1 week on the cloud, cost you quite much money, and then you analyze the results for the rest of the year or something, then it's definitely a case to use a cloud service. But if you're doing this every day, 24 hours per day or something, then you get to the point where it's actually very costly. I mean, the cost question here depends on your usage profile and the reality you live in. Let's say you have peaks, or you do pilot projects, or then you go on vacation for 2 months. Maybe you don't want hardware sitting there in your center just losing money. Maybe it was better to use cloud computing. But again, we're not talking about petaflop here. We're not talking about projects like Prace and CSC, Supercomputer Center. It's more like throughput computing, and that's where we are now. And another thing that's we are now here is that data is the hard part also, to push it up and do the crunching on the cloud. So some of the cloud providers already have data sets that they know you will need, maybe for to do some benchmarking. Maybe it's the common data set that everyone is looking at in life science or something. So they already put it there. So you don't have to upload, like every customer is uploading the same kind of genomic data. Instead, it's already there, so you can start playing with it and see if your way to look at this same data is more unique than someone else. So, but again, cost was not mentioned very much here, and I'm happy about that, because usually it was only about cost, the most cloud meetings. We now start to talk about what we can do with clouds instead. That's good.
Before concluding, I'd like to hear 3 words from each of the panelists describing which are the biggest obstacles in, let's say, harnessing the power of clouds right now.
Security, SLA, and territories.
I think it's misunderstandings. What's being delivered, who is in charge of what part, and so on. I mean, people have to think in a completely new way now, and you guys, the big companies, need to educate them.
27.
And yes. Oh, it was an SMS of 3 words, sorry. I can't do that.
If I speak then as a service provider, I would say for our customers benefit, understand where it is best applicable. I mean, if we can provide a service for geese data that is based on virtualized cloud technologies, we should do it there. And if we have the supercomputer is better for it, we should use that. So to find the cases where it is most applicable.
I think I would say just one word, and that word would be knowledge. Knowledge about your own systems and your own data, and what is it that you're actually trying to get out of the cloud services, and what data you're going to be putting there. I think that's the biggest issue that we have currently at the moment. Whichever customer I talk to, they don't actually know the systems that they're using and the services that they're trying to get, or the data they're trying to use. So knowledge would be my word.
Choose a good integrator.
Okay.